Welcome to this new module where we will discuss digital storage, preserving your content. This is a part of our lecture series for the course, the introduction to the computers and their uses. It's an introductory information technology or computer science course. The purpose of this module is to discuss the advantage of using different storage devices. Now, be ready with your pen and paper, pencil and paper, and write down some storage devices or techniques you have used so far to store your information, your files, your documents, your pictures, and so on. Pause this lecture and write it down on a piece of paper. Then you can reflect in the later part of the lecture. So we are trying to learn here about storage and memory uses as the first part of the lecture. Uh, in general, this module, we will be teaching you the storage, memory, the difference between storage and memory. That's very important. Many times we confuse them to be the same thing, but they are not. We have to identify the storage hardware types. We will be able to discuss cloud computing concepts. We shall evaluate cloud storage options. We will explain how to secure the data in the cloud systems. We will identify enterprise and other storage options. We will explain how memory relates to storage and identify risks for Internet of Things. This is a new concept you will learn here, the Internet of Things, which is sometimes called IoT. And there are many places you will learn about these concepts. So I'm talking about this IoT. Now, computers and devices, they use both storage and memory in order to access and save data and information. You can say information, and that actually information is a broad word, and you can use data, you can use documents, images, pictures, all as the information. The memory consists of electronic components that store instructions waiting to be executed by the processor, data needed by those instructions, and those results of processing the data into information. So in general, if you think about storage, this is quite similar to a file cabinet, you know, in your classroom or in your office, at home even. We use the files cabinet to store important files, folders, etc. Digitally, in the computers, they have the similar facilities, but they are architectured in a different way than the file cabinets, of course. Storage in general, it is related to a long-term permanent access to the data and information. So therefore, it is strictly non-volatile, permanent. Most memory, on the contrary, holds data and instructions temporarily, therefore it's volatile. So storage is non-volatile and memory is always volatile. We have to remember this. Storage medium is also called secondary storage, and these are the locations where a computer keeps data, information, programs, applications, etc. Now, if you try to give some examples of the storage media, you can think about the digital storage, for example, the cloud, your Google Drive, for example, a storage hardware like hard disks, solid state device, devices, solid state drives, of course, internal or external drives, memory cards, USB drives, USB flash drives, optical discs, CD or DVD, for example, and tags. Cloud storage keeps information on servers on the internet. We can ask an open question. Is cloud storage really a virtual storage? I mean, we don't see any device when we store information on the cloud storage, right? But uh, the cloud computing, we will learn more about it. But at the back end of the cloud systems, there are providers. I mean, like G Drive, it is hosted by Google, and they do have some physical storage devices to store your information, but they are distributed and served via the internet, so you don't really care, you don't really understand, or you don't really care about where the files are actually stored. You don't have that information anywhere. In addition to programs and applications, user can store a variety of data and information on storage media on their computers and mobile devices, or on cloud storage. So a storage device is a hardware that records or retrieves items to and from storage medium. So this is what type of medium it is. It's a volatile or non-volatile. A storage device by definition is non-volatile. Writing is the process of transferring data, instructions, and information from memory, which is volatile, temporary, into storage medium, non-volatile medium. And reading is completely opposite. It is the process of transferring these items from a storage medium into memory. Storage and memory capacities. I mean, if you think about the capacity, then we have to quantify capacity as the number of bytes, that is the characters, a storage medium can hold. A gigabyte GB equals approximately 1 billion bytes. A terabyte is approximately 1 trillion bytes. So you can see in this table the storage term, the terminologies, and how many bytes are there, and the exact number of bytes you can see in the numerical expression. So you can see like terabyte here, 1 trillion, 2 to the power 40. But if you think about other scales, petabyte, exabytes, zettabyte, and yottabyte, so you can see that it is 2 to the power 80, a huge storage. The speed of storage devices and memory is defined by access time. So the access time measures the amount of time it takes for a storage device to locate an item on a storage medium. That is the first part. And the second part is the time required to deliver an item from memory to the processor. So the transfer rate is the speed at which the data, instructions, and informations transfer to and from a device. Transfer rate for storage are stated in kilobyte per second, megabyte per second, or gigabyte per second. So you can see in this picture the relative speed and uses for storage media. So you can see that in this picture, basically, as you go from bottom to top, the transfer rate becomes faster. So optical discs, that is CD or DVD, for example, they have slower transfer rates. Memory cards little higher, USB drives little more higher, hard disks even higher, SSD solid state devices they are high. And memory is really fast. The RAM, it's a temporary storage, so you don't deal with a lot of access. I mean, we don't need to spend a lot of time to access the physical device. It's inside the memory of the computer. The most common storage medium is the internal hard drive. That's the core of your computer, the core of the hardware of your computer. The hard drives the hard drives can store data either magnetically, you can have magnetic disks, or using solid state storage. The files stored on the internal hard drive cannot be accessed on other devices. If you put something on your hard drive, on your disk in the computer system, you cannot you cannot access it on the other devices. Magnetic hard disk drives have greater storage capacity and are less expensive than their solid state equivalents. When you talk about hard drive, it refers collectively to the hard disks and solid state device. So hard drive is basically hard disks and solid state devices. A hard disk or hard disk drive, HDD or HD, whatever you call it, it's a storage device that contains one or more inflexible circular platters that use magnetic particles to store data, instructions, and information. Desktops and laptops contain at least one hard disk, so something like that. The storage capacity of hard disk is determined by the number of platters that the hard disk contains, the composition of the magnetic coating on the platters, whether it uses longitudinal or transverse recording, and its density. So these are some technical terms. So the storage capacity of the hard disk is really determined by how it is built, the composition, and of course the orientation of its components. A platter is made of aluminum, glass, or ceramic and has a thin coating of alloy material that allows item to be recorded magnetically on its surface. The longitudinal recording aligns the magnetic particles horizontally around the surface of the disk with perpendicular recording, vertical recording. By contrast, hard disks align the magnetic particles vertically. Density is the number of bits in an area on a storage medium. A higher density means more storage capacity. Formatting is the process of dividing the disk into tracks and sectors. A track is one of the series of concentric circles on one of the surfaces of a magnetic hard disk platter. Tracks are narrow recording bands that form a full circle on the surface of the disk. Now, the disk storage locations consist of wedge-shaped sections which break the tracks into small arcs called sectors. A sector is an individual block of data or segment of the track. You can see the picture here. In this picture, you can see the tracks, for example. So these are the tracks. These are the sectors. So when you think about the tracks, these are the circles. The circles represent the tracks, whereas the perpendicular towards the radius of the circle, you have different sectors. A typical hard disk has multiple platters. Each platter has two read-write heads, one for each side. A read-write head is the mechanism that reads items and writes item to the drive. A hard disk head actuator connects to ARM that moves the read-write heads to the correct location on the platter. So you can see here In this picture, we we present multiple steps of working of a hard drive. So step one is the circuit board that controls the movement of the head actuator and small motor is here. Then step two, a small motor, it spins the platers while the computer is running. So once you start up your computer, this starts spinning. I- In step three, when the software requests disk access, the read-write heads determine the current or new location of the data. And step 4 is the head actuator positions the read-write head arms over the correct location on the platers to read or write the data. While the computer is running, the platers in the hard disk rotate at high speed. So that causes the spinning, right? This spinning allows nearly instant access to all tracks and sectors on the platers. The plater continues to spin or it may slow down after a specific time to save the power. The spinning motion creates a cushion of air between the plater and its read and write head. This cushion ensures that the read-write head floats above the plater instead of making direct contact with the plater surface. An external hard drive is a separate freestanding storage device that connects with a cable or with a USB port or to other port of any device. Sizes and storage capacities of the external drives may vary. I mean, it can be few megabyte in the past, or it can range from few gigabyte to hundreds of megabytes to few terabytes even. With an internal hard drive, an entire external hard drive is enclosed in an airtight sealed case. A solid state device is a flash memory storage device. Flash memory is a type of non-volatile memory. It's temporary memory that can be erased electronically and rewritten. It's not temporary, it's a permanent memory. The flash memory is, of course, a permanent memory that can be erased electronically and can be rewritten. Flash memory chips are a type of solid state media, which means they consist entirely electronic components and contain no moving part. In this picture, you can see a typical solid state device. So in this picture, you can see that there is a case for the solid state device. The internal SSD that is installed into the laptop. That's the picture of that. Basically, inside of SSD, you can see it's an array of chips. And of course, there are circuits, there are connections to make it working. Portable flash memory storage example is a memory card, for example, is a removable flash memory storage device. These memory cards enable mobile users to easily transport digital photos, music, videos, or other files to and from mobile devices and computers or other devices. A slot on a computer or device accepts multiple types of cards. A USB flash drive. So USB is the abbreviation of Universal Serial Bus. This is a removable storage device for folders and files that plug in a USB port on a computer, making it easy to transport folders and files to other computers. So this is shown in this picture here. We use it frequently, right? The storage capacities of USB flash drives and memory cards, they do vary. I mean, you can find like other storage devices, they can range from few gigabyte these days. In the past, they used to be megabyte level of USB devices, but right now they can range from few megabyte, let's say 4 megabyte, 8 megabyte, up to few hundreds, 500 of megabyte, sorry, 500 of gigabytes. So it's safe to say that, I mean, today USB drives are uh, pretty comfortable in accommodating large volume of data, large volume of information. There can be optical media as well. The optical medias are mostly the CDs and DVDs or maybe the Blu-ray discs, but these days their uh, their usage as storage media is not very abundant. Their usage as storage media is fast declining. An optical disc is a type of storage medium that consists of a flat, round, portable disc made of metal, plastic, and lacquer that is written and read by laser. You can see the characteristics of optical disc formats in this table. So CD drive, for example, CD discs, they can have three different drives formats: CD-ROM, CD-R, and CD-RW. So ROM means it's read-only, CD-R means recordable CD, and CD-RW is rewritable. So typically we use audios and photos when we use the CD. DVD, on the contrary, it can have read-only DVD-ROM, DVD-R or DVD plus R. This is recordable. DVD dash RW or DVD plus RW, and DVD dash DVD plus RAM, they are rewritable. So mostly they are used for video, and Blu-ray is a higher capacity disc than DVD, and this is also video. You can start a discussion about HDD and SDD, and you can think about what are the advantage and disadvantage of each. Typically, you go to um, internet or you read your textbook to find out more information on HDD and SDD, hard disk drive and solid state devices, and then you can form some table that can where you can note down the advantages of and disadvantages of each of them. Cloud computing is a very interesting buzzword these days. Home and business users choose cloud computing for accessibility, cost saving, space saving, and scalability. And of course, it is pretty cheap in terms of maintenance. You don't have to dedicate your time to maintain the cloud storage. But but it comes with some cost. But if you think about normal storage, this also comes with cost. You have to buy those and you have to regularly maintain those. An example of cloud storage, we can come up with your uh, Google Drive, for example, maybe the box. I mean, those are the simple cloud storage examples. There can be more sophisticated cloud storage systems, and there are cloud storage systems that can be associated with programming interfaces. Now, cloud computing has two parts, the front end and back end, and these are connected to each other through a network, typically the internet. The front end includes the hardware and software with which a user interacts to access the cloud. Your computer, for example, you can use your computer, that's the hardware, and also your operating system through which you initiate some internet connection, your network connection, and, and connect to the cloud computing interface. The back end of the cloud computing system consists of servers and storage devices, a typical data center that manages and stores the resources accessed by the users. Cloud computing system allows the enterprises to outsource or contract to third-party providers elements of their information technology infrastructure. Cloud storage providers enable you to synchronize files, write documents, backup files on your computer or mobile device, share project work, stream music, post photos, and play games online. So typically, when you go to YouTube, for example, and you can store your videos on the YouTube, you can make a video and store the video, so you can stream the video through the YouTube, and you also get the storage services for the YouTube, and that's practically for free. In addition to software as a service, consumers and organizations rely on cloud computing services to manage infrastructure as a service, storage as a service, desktop as a service, data as a service, platform as a service. So when you talk about software as a service, typical example is your Canvas. So somebody else built the software, they deployed it to a server that is not visible to you. You know, don't manage that server, but you access them and you do your school work. The school maintains their uh, academic stuff on the, I mean, day-to-day academic stuff, the learning management system through the Canvas, and that's an example of your software as a service. The infrastructure as a service is a little bit more comprehensive. For example, um, Amazon Web Service, I mean, it has EC2, Elastic Computing interface, where you can choose a server, like you may choose Windows, Linux, Mac, whatever operating system. You can build a device kind of thing, build a server, then you can populate the server with the software that you need to maintain your application, and you can deploy your application to the server, and then that server can make those information available to your clients. So basically the need for handling the infrastructure, the computing resources, the software operating system resources, uh, you don't have to do those. You are paying uh, usage fee, I mean fee per usage to the cloud system, and then in exchange you get your infrastructure hosted and distributed over the internet to your end users. The storage as a service is a little bit different here, like you have the Google Drive, for example, that's a storage as a service. So basically um, when you sign up with Google, you get typically 15 gigabytes free, and then any uh, any sizes over 15 gigabyte, you have to pay some fee, and that fee is, I mean, that fee, they have a structure of the fees depending on your storage needs. The data as a service, basically there you provide the data. I mean, basically you host your data and you can use your data there. Sometimes, we use infrastructure as a service. We use a lot of databases platform, and so uh, the database platforms, they serve as the storage for the data, for your data. But you can also have independent data service through your cloud system, and that is little bit complex to design by the providers, but it's pretty easy for usage to use. The platform as a service is basically, here you don't care about the infrastructure, so you don't maintain the infrastructure. You just use a platform to deploy your services, and then whenever a request is initiated by the user to access your services, the platform serves those services to the user. An example, you can think about AWS Lambda. There are some additional cloud services. They are synchronize files, write documents, backup files, and stream media. These are all important aspects of cloud computing. To illustrate more on data as a service, here we can say that this is a platform provided by multiple cloud providers, different cloud providers. This is designed to enable data providers to build and offer data related products, services out of the box to their subscribers. So you can think about stock market, and every day trading happens, and there are providers that can serve you the data. For example, there are multiple stock exchanges, let's say Nasdaq. Uh, you can access Nasdaq, and then you can design your stock screeners on the Nasdaq and download the CSV files, the Excel spreadsheets about the daily stock prices, hourly stock prices, whatever you want. Sometimes those are free services, sometimes you have to pay fees to get those services. Now, finally, what we did not speak about, that is desktop as a service. This is a cloud computing offering where a service provider typically delivers virtual desktops to end users over the internet, licensed with a per user subscription. So you can have some desktop. You have to log into the desktop using certain credentials supported by the enterprise. I mean, maybe that's a school desktop. You access it through your home computer, providing your credentials, school's credentials. So you get the desktop, a custom desktop built for you, served over the internet, and then you can do your computing on the desktop. So those are the examples of desktop as service. You can see a snapshot of the Google Drive. You can see that you have like you have a My Drive, you have all the files stored here. As you open the Google Drive, you can see the My Drive. That is your drive actually, the main disk of your drive. And then you see all the folders there, and inside the folders you will have a lot of files. So that's how you have the Google Drive designed. And you see here these tabs, they are the functionalities of the Google Drive. Even these functionalities can be accessed using programs. You can write a Python program that can access your Google Drive, you know, and then read those as if the files are stored on your own devices. So basically, you have to do some networking libraries in order to access the Google Drive. Let's check some knowledge. Cloud computing connects dash and dash through a network. What is the right answer? Hardware and software, server, storage, online, offline, front end, back end. Which one is correct? So the answer D is correct, front end and back end. There are multiple options for the cloud storage with Google Drive or Microsoft OneDrive or Box. I mean, that is also another cloud storage option. They are primarily used um, for storing your files, and you can also grant other users access to those files. The files are protected by security protocols, including the passwords and identification requirements or encryption, and they are regularly backed up to other servers so that the outages in which access is limited or denied are rare. The advantage of relying on cloud-based storage is the flexibility of not having to purchase and maintain your own servers. Photos, songs, videos, I mean any information, those take longer to upload than smaller text files. So it is important to select a provider whose servers have sufficient bandwidth and whose servers are elastic, kind of they can uh, the bandwidth can expand or contract according to your need. Criteria to consider for provider include the amount of free storage offered. Like I said, Google Drive offers you 15 gigabyte of free storage. Then the cost to purchase more storage. Google Drive, for example, offers a nominal price if you expand your storage size from 15 gigabyte to 50 gigabyte, 15 to 50, 15 gigabyte to 50 gigabyte. Then they charge you a very nominal fee. The maximum file size, there can be restriction on the maximum file size that each service allow you to upload. As an example, Google Drive will allow you to upload a file size um, up to 5 terabyte. Now, users who reach the 750 gigabyte limit or upload a file larger than 750 gigabyte cannot upload. I mean, there can be multiple tiers, for example, but individual file size maximum you can upload with your proper plan is 5 terabyte for the Google Drive. So this 5 terabyte size is not, there is a restriction there. For example, um, each user can upload and copy 750 gigabyte to Google Drive within 24 hours. Now, the user who reaches the 750 gigabyte limit, they cannot upload or copy more files until the limit refreshes within 24 hours. So you can upload and synchronize files up to 5 terabyte in size. So that is how this 5 terabyte number is found. It's not a daily limit, it's total limit, but daily you can upload 750 gigabyte. That's pretty comprehensive. It is also important to read about the cloud storage provider's privacy policy and terms of agreement to which you must consent before you use provider services. Sometimes, you have to very careful about what you are doing because suppose you are dealing with some sensitive data. um, I mean, it is very important for the from the regional perspective as well. Different world region may have different restrictions in place. If you do a global business, for example, if you do business in Europe, the European Union has very strict uh, law regarding where the data can stay, whether it can stay outside the political or the regional barrier or not. So you have to review those information very carefully. If you are dealing with the healthcare data, for example, you have to keep in mind about the HIPAA laws, and you have to make sure that whatever storage media you are using, their privacy laws cannot contradict the HIPAA. So basically, you are using it for a business, then it's your responsibility to review the privacy policy and whether that aligns with your business policy. I mean, with the business policy or with the policy that the governments or authorities imposes on those kind of data. So these are very important factors. So, three things. First of all, the bandwidth consideration. Number two is the storage consideration. Number three is the privacy policy consideration. Now, you should consider the following guidelines when selecting a cloud storage provider. So, you have to verify that company is reputable because you are storing your information there. That's not only not only privacy issues, also the information, if that is lost, then that will be a huge loss for you because you are not preserving any paper copy. It's assumed. Choose a provider that encrypts your files. It's security stuff. You need to determine if the provider's service is compatible with your computer and mobile devices. You should not use something uh, which which does not provide any application for your device, particular device types. You need to compare the price of various storage plans and choose a provider that offers competitive pricing. You need to verify that cloud storage provider will support the types of files you want to back up. If desired, choose a cloud storage provider that allows you to share selected files with others. You need to consider whether the providers offer a mobile app. That's very important these days, that you can use to access your files using a mobile device, a tablet, or even a cell phone, a smartphone, for example. Cryptocurrency, I mean, now when we talk about securing our data on the cloud services, uh, cryptocurrency is a digital currency instrument that can be used to transfer money payment between users or corporations. It's not backed or secured by a government. Cryptocurrency, for example, is not backed or secured by government. There are payment apps such as the Venmo, maybe Zelle, that enable you to transfer money between your credit card or bank account to other user. You can pay a merchant using Venmo or PayPal or, for example, Zelle. There are multiple payment apps. A digital wallet such as Apple Pay is an app that is connected to a specific payment card or financial account. So these are very important stuff. I mean, these all modes of payments are these all these modes of payments are very important to consider because um, payment applications very important to consider because a lot of security is associated with those. Some steps to protect your cloud-based data include choose your cloud providers carefully. Uh, I mean, whether you are using a web-based app that also offers storage such as Google Drive or using an online backup system, read the user agreement, set the most advanced privacy settings that your service allows. The strong password needs to be used, and of course, the two-factor authentication to protect against unauthorized access. Do not store sensitive data or other information without ensuring that they will be encrypted. Enterprise hardware allows large organizations to manage and store data and information using devices intended for heavy use, maximum efficiency, and maximum availability. High available hardware is accessible 24 hours a day, 365 days a year. To meet the needs, enterprise hardware includes levels of redundancy. You know, redundancy is a word, but in the concept of in the context of the disks, computer disks, for example, you store some file on a disk. So when you call about redundancy, that means you have a backup disk, I mean one or more backup disk where your data is always backed up so that if this disk is lost, then you can restore it from the backup disk. This is the simplest form of redundancy, but it can be designed in a more complex way so that the data loss probability is extremely low or negligible. Enterprise storage centers or a data center is a secure location with many large computers that act as servers, making files available to users. Some enterprises manage an enterprise storage system in-house. Others select to outsource all storage management to an outside organization or cloud storage provider. A group of two or more integrated hard drives called RAID, redundant array of independent disks. RAID may duplicate data, instructions, and information to improve data reliability. That's what I was talking in the previous slide. For example, you have a computer where you have a lot of where you enter, where you enter some information. Now, this information is stored on a device on a hard drive. Now, RAID actually ensures that it has a strong backup system, replication system, so that your data is never lost. So it may be associated with different types of RAID systems. So basically, RAID backs up your data, duplicates your data in a way that if your disk is gone, RAID can be used to restore your data. A simplest RAID storage design is level 1. That's the mirroring, which writes data on two drives at the same time to duplicate the data. That's what I was talking about. So you can see this is A, this is the main disk, and this is the backup of A. This is the level 1 RAID device. Other RAID levels are use a technique called stripping, which splits data, instructions, and information across multiple drives in an array. This is kind of stripping. Stripping improves drive access times. You can have network attached storage or NAS. This is a server that is placed on a network with the sole purpose of providing storage to users, computers, and devices attached to the network. The NAS server, often called storage appliance, has its own IP address, usually does not have a keyboard or display, and contains at least one hard drive and one configured in a RAID. Administrators can add storage to an existing network quickly by connecting a network attached storage server to the network. A storage area network, the SAN, is a high-speed network with the sole purpose of providing storage to other attached servers. Now, a storage area network includes only storage devices. High-speed fiber optic cable usually connects other networks and servers to the storage area network so that the networks and servers have fast access to the large storage capacities. A storage area network can connect to networks and other servers that are miles away using high-speed network connections. There can be other types of storage as well. that can include tape, magnetic stripe cards, smart cards, RFID tags, and NFC chips and tags. Find out more about, for example, these type of storage media. Do a search on internet, do Google those items and find out more information. Write on the piece of paper on your notebook while you are listening to this lecture. Pause this video and go and find out more information of RFID and NFC chips and tags. Then move forward. Now, tape is a magnetically coated ribbon of plastic that is capable of storing large amount of data and information at low cost. Um, there used to be some VHS tapes to in the early times when you just use them to store the movies. You can for the movies they used to sell the VHS tapes. The magnetic stripe card is a credit card, entertainment card, bank card, or other similar card with a stripe that contains information identifying you and the card. A smart card, which is alternative to magnetic stripe card, stores data on an integrated surface circuit embedded in the card. Two types of smart cards called contact and contactless. I mean, if you go to the store use a credit card, for example, if the credit card has an internet sign on it, that means you can simply use it in a contactless mode. A contactless credit card is something like this. I mean, you can have a chip enabled there. This can be contactful or contactless, depending on how the system is architectured. It usually, I mean, sometimes you can have it working like a contactless chip. For example, if you have something like this, just like that, let me go there, type. So if you have this symbol, this wireless symbol, if you see here, then it is an indicator that it is contactless. So all vendors they have these days they used to provide you with contactless card, specifically after the coronavirus pandemic era, so that we want to keep things contactless so that there is no infection carried over by your payment cards. A smart card, which is an this is always I mean this contactful and contactless cards. The magnetic stripe card, alternative to the magnetic stripe card, both of them are examples of the contact and contactless card. They are example of smart card. RFID tag consists of an antenna and memory chip that contains the information to be transmitted via radio waves. An RFID reader reads the radio signal and transfers the information to the computer or computing devices. The RFID tags are either active or passive. NFC is a technology. It's based on RFID that uses close range radio signals to transmit data between two NFC enabled devices or between an NFC enabled device and an NFC tag. NFC-enabled devices contain an NFC chip. NFC tags are self-adhesive so that they can be attached to any location. So a very simple example of NFC-enabled device is your Apple iPhone. That's an example. You use the digital wallet, I mean Apple Pay there. That is basically um, that basically uses near field communication or NFC technology between your device and the payment terminal. So NFC devices, I mean, like your iPhone, for example, NFC devices are not just used as payment mode; they can be used as a key to your house as well. An NFC tag similar to RFID tag contains a chip and an antenna that contains information to be transmitted. You can use, NFC communications include using a mobile device to pay for goods or services, that Apple Pay, for example, displaying a web page. So you scan something and then your web page is displayed, making a phone call, sending a text message, or exchanging contact information. And also, your home key, more advanced apartments or houses, they can use a NFC enabled key. This section, we are going to study how memory relates to storage. A memory usually consists of one or more chips on the motherboard or some other circuit board on the computer. Memory stores three basic categories of item: the operating system and other programs that control or maintain the computer and its devices, applications that carry out a specific task such as word processing, the data being processed by the applications, and the resulting information. A byte, a character, basically a byte, is the basic storage unit in memory. When applications, instructions, and data are transferred to memory from storage devices, the instructions and data exist as bytes. One byte, each byte resides temporarily in a location in a memory that has an address. An address is an unique number that identifies the location of a byte inside the memory. To access the data or instructions in the memory, computer references the addresses that contain the bytes of data. Memory capacity affects the device's operational speed. For example, RAM is the most common type of volatile memory, temporary memory. Examples of non-volatile memory includes ROM, the flash memory, and CMOS. RAM is also called the main memory, that consists of memory chips that can be read from and written to by the processor and other devices. RAM can accommodate multiple programs and applications simultaneously. Saving is the process of copying the data, instructions, and information from RAM to a storage device or to the cloud. Today's computers improve their processing times with cache, which is a temporary storage area. Memory cache helps speed up the processes of the computer because it stores frequently um, used instructions and data. So basically, the cache is a very effective thing because for some applications, let's say you are developing a software program down the road in your computer science course, you are developing a program that actually accesses a database to find some information. Now, it may so happen that your database has the same information all the time. So, rather than accessing the database, your computer, your program may choose, you can use the cache technology to temporarily store the data that you are otherwise accessing from the database into the cache. What is the advantage? The advantage is your access time to the database is much larger than access time to the memory cache because it's essentially in your program memory. So you can have those memory readily available whenever you need those. So in this picture, you can see there are multiple, the correspondence of the memory to the storage. So you see when you start the computer, certain operating system files are loaded into RAM here from the hard drive. The operating system displays the near interface, the user interface on the screen. When you run a browser, the application's instructions are loaded into RAM from the hard drive. The browse and certain operating system instructions are in the RAM. The browser window appears on the screen. Step 3, when you run plain um, a paint application, for example, the application's instructions are loaded into RAM from the hard drive. The paint application, along with the browser and certain operating systems instructions, are in RAM. Step 4 is when you exit an application such as the browser, its instructions are removed from RAM. The browser no longer is displayed on the screen. Now, what is ROM? ROM is read-only memory. It refers to memory chips storing permanent data and instructions. The data on most ROM chips cannot be modified, so that's why it is called read-only. ROM is read-only memory. Manufacturers of ROM chips often record data instructions or information on firmware chips when the chips are manufactured. These chips contain permanently written data. The flash memory is a type of non-volatile memory that can be erased electronically and rewritten. Your USB drive, for example, you can delete those files from your USB drive and replace them with some other information. Most computers are, most of the computers can use the flash memory to hold their startup instructions. Flash memory chips also store data and programs on many mobile devices and peripheral devices, such as smartphone, portable media players, printers, digital cameras, automotive devices, and digital voice recorders. Some portable media players store music on flash memory chips. Others store music on tiny hard drives or memory cards. Memory cards contain flash memory on a removable device. Some RAM chips, flash memory chips, and other memory chips use complementary metal oxide semiconductor or CMOS technology, as it provides high speed and consumes little power. So CMOS technology uses battery power to retain information even when the power to the computer is out. Battery-backed CMOS memory chips are important in this context, and the flash memory chips that store a computer startup information often use CMOS technology. Now, again, we have to think about the ethics and issues. So, every day, smart electric meters, wearable technology, and vehicles back boxes submit data about us, a part of Internet of Things. So when you talk about Internet of Things, you think about orchestration or a network of large number of different heterogeneous devices. You can have a network where you have for example, you can have your smartphone. They can be connected, your main computer, let's say your solar panel. Sometimes you have your cars connected to it. You can have TVs, smart TVs. You can have your washer dryer enabled through IoT. Commonly, what they use sometimes is that they integrate those devices to certain um, to certain network, Wi-Fi network, let us say, and then your all the devices are connected to the Wi-Fi devices and Wi-Fi connection, and then they communicate to each other through those through that connection. So you can so basically your I mean so this is what is formed this is what is called as IoT or Internet of Things. Now these devices could have default settings that prevent sharing of data until so you have to ensure they are secured. So the devices they have default settings they can have default settings that prevent the sharing of data until obtaining the consumer's consent. Companies bear responsibility of ensuring sensitive data being collected is kept secured and confidential. Privacy and security concerns about abound with the IoT. Technology experts believe that the security, health, and productivity benefits of this technology outweigh the potential risks. So you can uh, do a case study. For example, Amazon ships products from more than 50 distribution centers. At times, customers will need to return their merchandise and have the charges returned to the credit card on file. To provide their best customer service, Amazon has partnered with a few large departmental store chains to handle their customer returns versus having the customers pay to ship the item back to receive the credit. To ensure this is done accurately, the department store has access to process the return and return the charge to the customer's credit card on file. What type of access and storage does Amazon use in order for the department stores to gain the access and process the returns properly? So this is the case study. Just go on to Amazon and try to find this information by researching. So you can say like what type of storage process is needed to accommodate these type of transactions in general. Is it cryptocurrency? Is it digital wallet? Is it cloud app? Is that data center storage? Which one is right? The the data center storage number D, that is right. So basically, if you store this information at a data center, then it is easier for Amazon to track all the activities because that's part of the server. Now, for the self-assessment, I would recommend you to approach these questions, try to find out the answers. Do you use cloud computing or storage in your own life? How useful is it for you compared to the hard disks? Number two, have you ever lost an important document or photo from your digital storage? Did you put something in the Google Drive and you found it's no longer there? I mean, you did not delete it, of course, but it's gone. How do you plan to safeguard your digital files to avoid losing the important files? So, there is a cool fact with the Facebook storage. The storage system can also be configured for availability, the 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 time of availability, because Facebook typically stores a huge amount of data. So if it tries to serve all the amount of data at the same time, then it will require a huge amount of computing resources. So they have done it very intelligently. They designed the storage device in two categories. Cold storage, that is basically the data, file, photo that people don't use very frequently. They put it in the cold storage, like in a storage that is not accessible very fast. But and there are hot storage device that is available immediately. So that is some example. You can search your web, search the Google for understanding more about Facebook storage systems, and then you will understand more about the configurability of the storage systems in terms of the access times as designed by the Facebook. So these are the things that we have learned. So in this particular lecture, we went through some important topics of storage devices. I mean the storage basically. So we learned about storage and memory. You know, the storage is permanent, memory is temporary. You have to understand that. You have to identify, we have identified storage hardware types. We discussed cloud computing in details. We evaluated cloud storage options. You will find some questions in your assignment about it. We explained how to secure our cloud data. We identified enterprise and other storage options. We explained how memory relates to storage. And finally, we identified the risk for Internet of Things. And as per the recommendation of from different networking companies or networking people, they say that the risks, that the benefits, they are larger than the risks with the IoT devices. So, any question, please comment, please show your comment or uh, contact me directly and we will be in touch. Thank you. Talk to you later.